Hello, in this video I'm going to continue our tour of the universe with another type of object that's found outside of the solar system, and that's nebulae. So these are star formation regions, and this is something we need to be careful with when we start using this word. So nebulae, plural of nebula, because the word is still hanging around in other types of object that aren't star formation regions. So we need to be clear right from the outset what it is we're actually talking about. Now, the reason this word gets thrown around quite a lot is this pretty much means cloudy. And if you go back to the early days of astronomers with telescopes looking at deep sky objects, so say the 18th century thereabouts, and you've got people looking at galaxies, these nebulae, planetary nebulae, supernova remnants, all of them looked much the same to them in the sky. They couldn't tell one thing from another. They couldn't look at, say, the Andromeda galaxy and say, oh yeah, that looks like a galaxy. They couldn't see the spiral structure. So they referred to all of these things as nebulae. They were all just cloudy. They were diffuse, smudgy looking blobs in the sky. Now, for some of these objects, the name has stuck. So planetary nebulae I've just mentioned. Planetary nebulae are, that's an end state of a star in its life. And I'll be doing a separate video on those because they're interesting objects. But they're not star formation regions like these are. It's the end of a star's life. You've got a similar thing with the Crab Nebula. So you take M1, the Crab Nebula, that's the first object in the Messier catalogue. That is a supernova remnant. It's, again, the end of a star's life. It's not a star formation region. So the nebulae that I'm talking about here are vast, vast clouds of gas and dust within which you get star formation. So this picture here, which is a popular one for astronomers in the northern hemisphere, it's actually visible with the naked eye. Obviously, it doesn't look like this with the naked eye. You need a pretty decent setup in order to get a view of it that looks anything like this once you've processed your photo. But this is the Orion Nebula. So this is located just below Orion's belt. The three stars in the center of Orion is just sort of below those. And this is designated M42 in the Messier catalogue. So you've got something like the Orion Nebula. It's a really, really big cloud of gas, but this isn't even one of the bigger ones. So it's 1,300 light years away, but the full extent of it is larger than the full moon in the sky if you get the whole extent of the nebula. So that is pretty big. You're looking at something which is about 1 degree across in the sky. So you think how wide that's got to be if we're 1,300 light years away, and then we're still creating an angle of 1 degree. I mean, it turns out, you can do the trig on this. It comes out that it's about 25 light years across. So that's pretty big. That's, as I say, not as big as nebulae get. We're going to look at, the next slide, I'll be showing the Rosette Nebula, which again isn't necessarily a crazily big one. It's further away. It's about 5 times the diameter of the Orion Nebula. You're looking at, people have found about 2,500 stars in it so far. So yeah, these are huge, huge clouds of gas, and they're slowly contracting. Essentially, they're hydrogen plus dust. By dust, you just mean sort of any other sort of bits and bobs, leftovers of old stars that have in interstellar space. You get these clouds of hydrogen around. You'll get a few other bits maybe of other elements, but it's mostly hydrogen with various other larger sort of molecules, but it is mostly a hydrogen cloud. And this starts contracting under gravity, and you'll get dense bits. So you'll get sort of dense patches forming in various places. And of course, if you get a dense patch, it pulls more matter in and it gets more and more dense. And then eventually, this process will accelerate and you'll end up with a star. You'll get enough matter contracted in one place that you're then going to get fusion kicking off. And once you start getting stars forming inside this cloud, it's the stars are then going to ionize all of the, well, not all of it, but a lot of the hydrogen gas. That's going to start glowing, and you're going to start seeing these things in the night sky. So, and they make these really nice patterns. So that's what's happening, and that's how you get the two different ways that they classify these nebulae. You get H1 and H2 regions, depending upon the ionization state. So you'll quite often see these Roman numerals put after elements in astronomy, and that's giving the ionization state. So if you've got a Roman numeral 1, that means it's neutral, it's not ionized. If you've got a 2, it means it's got a single ionization, it's a +1. So, and then of course in hydrogen you can't ionize it any more than that, there's only one electron, so that's as far as it goes. Whereas with other objects, you might see, like O3 is a popular emission line that you'll get in, say, planetary nebulae. So that means you've got O2 plus is sitting in there, and then you're getting emissions from energy transitions in oxygen. So yeah, a lot of these are then the ones we're looking at here with nice fancy pictures. These are H2 regions with ionized hydrogen. Now, another thing that we need to be clear on is when I'm saying that these things are clouds of gas and dust. Now, they are clouds of gas and dust, but don't think that they are in any way dense clouds. Now, it looks like there's a lot of stuff in the picture, but remember, this is 25 light years across. They're nowhere near as dense as clouds or even air on Earth. So, air on the Earth, you might have 10 to the 19, something like that, particles per cubic centimetre. In a nebula, you might be looking at 10 to the 4 or less than that. So they're in no way dense. These are very diffuse clouds on average. The average density, obviously you get higher density when they start clumping together and forming stars, but the average density is low. But yeah, I mean, this is where we're actually watching in slow motion, admittedly, but we're looking at stars being born, which is quite an astonishing thing to think about, really. So to go through, let's sort of wrap up then with a few famous nebulae and what they look like, so you might be able to recognize some of them. This is the Rosette Nebula, which I mentioned before. So this is about 5,000 light years away. It's about 130 light years across. Rosette Nebula, I mean, you have to use your imagination a little bit with these in order to pull out the shapes, but you can see the sort of, patterns where you've got this sort of rosette look going on. It does look a bit like the sort of thing that they hand out at prize givings and sporting events. So, like I say, you have to use your imagination. But yeah, that's the Rosette Nebula. That's quite a big one. Another popular one here is the Tarantula Nebula. Now, this is a mega nebula. It's a really, really big one. So much so that this is actually in a different galaxy. This is in the Large Magellanic Cloud, which is an irregular galaxy that orbits the Milky Way. It's a satellite of the Milky Way. Now, we can't see that in the Northern Hemisphere. It's only visible in the Southern Hemisphere. But this is really, really bright. The fact that we can see this at all is nuts. This is in a different galaxy. But if it was as close as the Orion Nebula, so 1,300 light years away, it would actually cast shadows. It is that big and bright. But yeah, this is Tarantula Nebula. Again, you've got to kind of work on your imagination, but I don't know if I'm picking out the right bits here, but I would say if this was me, you've got like the body of a spider there with some legs coming out, this sort of thing. So that's what I'm saying, is there maybe some fangs. By the time you draw on enough lines, you can turn it into anything. But yeah, that looks more like a beetle, but still, that's what I'm seeing as a tarantula. People might pick out something else. It's like looking at clouds, isn't it? You can turn them into anything you want. Right, this is another bright one. I think this is actually visible with the naked eye, I think. It's the Lagoon Nebula. So this is M8, so the 8th object in the Messier catalogue, the Lagoon Nebula. It is located in Sagittarius, and so you don't want to be too far north for looking at things in Sagittarius. But there's a lot of stuff in Sagittarius because the centre of the Milky Way, the centre of our galaxy, is located in that direction. So you're looking towards where most stuff is if you're looking into Sagittarius. You're looking towards the bulk of the matter. So we're back here inside the Milky Way, just as we are with the Rosette Nebula and Orion Nebula. And yeah, I mean, I suppose Lagoon, they're desperate for something to say. Although it does look a bit like those tropical lagoons that you get with a coral reef sort of atoll thing going around it, but not a whole load of features in this one. So Lagoon covers a multitude of options, but it's one you'll see a lot of pictures of. What have we got now? We've got, what is this? This is Trifid Nebula. The Trifid Nebula is, I didn't write this one down. I think it's M20. Yeah, I'm going to go with M20. I mean, look it up. It's south again. I've never actually seen a Trifid Nebula. I've never observed it myself. You can ask yourself what a Trifid looks like, and well, again, you can do whatever you want on that, seeing as they're not real. But it's a very distinctive looking nebula. Again, it's in Sagittarius, so you're looking a bit more south. It's not ideal for looking at it from the UK. It's not too far south, obviously. It's got a Messier designation. Sagittarius, it's still within reach. But yeah, I'm pretty sure it's M20 Trifid. It's the one I forgot to double check on before starting this video with the Messier numbers, but we'll go with that. So that's another distinctive one. Then we've got the Eagle Nebula. This is M16, and you can sort of see an eagle effect going on here. Wing there, tail there, beak. Yeah, there you go. That looks like an eagle, doesn't it? So yeah, really nice looking one there. Nice bright sort of reddy pinky colour. And the Eagle Nebula, that got into the news quite a lot with back in the 90s. You might have seen this picture here that came from the Hubble Space Telescope back in the 90s, where you got the pillars of creation. And this was Hubble zoomed in on the Eagle Nebula and found these really dark sort of fingers extending in one part of the nebula, and these are thought to be actual star formation in process, that these are the step away from actually being a star, that we've got to really dense regions, things are clumping together and accelerate on quite a while, but this is as close as you can necessarily get to seeing it. This is like the step before having a protostar and something turning spherical and then pulling in enough matter to kick off fusion. So you're looking at those real dense bits inside a nebula where stars are really beginning to take shape. So hence the name Pillars of Creation. And I mean, this was splattered all over the news for ages. It's an amazing thing to see. I mean, it's just astonishing image, especially as it was showing the value of having the Hubble telescope up there after all the trouble that it had with the mirror and having to get it corrected, and it could only look at certain things when it was first up there because the mirror was sort of a hair's breadth out of being the right thickness, and all of these issues, and it was getting a bit of sort of mockery thrown at it, the Hubble, that it was going to be a complete waste. And then it was all fixed, and here you go. We're looking back at the origin of stars here. It's just worth its weight in gold, really. More so the Hubble Space Telescope, because it's not that heavy. So yeah, that just sort of rounds off actually seeing these processes going on deep inside these nebulae. So yeah, they're amazing things. They're one of the types of object that really drag people into being astronomers. Well, maybe drag isn't the right word, because that sounds like it's against their will, but sucked into being astronomers because they're just so great to look at, and they're just so mind-boggling that you're actually looking at stars forming. It's just crazy stuff. But they're a real challenge to get these pictures. I mean, looking at these sort of let's find one that I haven't drawn all over. So going back here to the Trifid, I mean, you don't just come up with a picture like that, and it doesn't look like that when you look at it through an eyepiece. I know I said I haven't looked at the Trifid Nebula, which I haven't, but I've looked at other nebulae through telescopes, and they're never going to look as good. Obviously, these are created by professionals, but the pictures that you get come over very long exposures. So you'll set up your camera or digital camera or your CCD or whatever other detector you're using, and you will have long exposures over these. I mean, back in the day when people were taking with a camera with actual filming, they'd be setting off half an hour exposures, things like that, because you've got to gather a lot of light to get this detail. They might be letting out a lot of light, but they're letting out a lot of light over a big area. So in terms of getting this level of resolution and contrast, then you need to expose the camera film or the CCD or whatever other detector you've got over a long period of time, so it can gather enough information, so it can gather enough light. And that's not an easy thing to do, because you need to have very good equipment to track the motion of the object across the sky over a prolonged period of time. So you've got a lot of challenges there. It helps if you've got a bigger telescope because you're getting more light just in general, so that can help. But you've still got to track these objects very well, very accurately, and over a long period of time. And then you've got the processing of the information after that. That adds in a lot of the color. Then a lot of the colors on these are enhanced, so they look a lot more washed out when you actually look at them through a telescope. So if you were looking at the Orion Nebula through a backyard telescope, which a lot of people would have done, then you're certainly not going to see that sort of detail that we had right back on the first slide. Where's it gone? Orion Rosette Nebula. Here we go. Orion Nebula. It will look nothing like that, but you will be able to see the extent of it. You might see a little bit of structure at the top that you've got the like the big cloud with a little bit sort of separated. You can see that sort of thing, but you won't be seeing all of these wisps and dancing reds and pinks and all of that sort of thing going on, which is a shame, but it's another thing that pulls people into doing astrophotography, because you can create things that don't look quite as good as this, but you will still pull out a lot of the detail. So that's nebulae. I mean, they're relatively easy to understand at a basic level, star formation regions, and then it's nice to look at the pretty pictures, really, isn't it? So I'll come back in the next video. I think I'll carry on with planetary nebulae, so we can underline the fact that the two things, nebulae and planetary nebulae, are very different to each other. So I think I'll bring that one up next.